So this unit that we have been on, it's been about quadratic functions, right? And we know that quadratic functions are different from linear functions, and that linear functions, there's always a constant rate of change. It's the same thing that's happening over and over again, right? If we were to say Armani went to the bank and she had some money in the bank and she decided that every week when she get paid, she's going to put $20 per week in the bank, right? What kind of function are we talking about if she's putting the same amount of money every week in the bank? A linear function. So if they were to give me something like that on the ELC, I know that we're talking about linear functions, right? So when we talk about, let's say, the system of linear functions, let's say, for example, our money goes to the bank, she deposits some amount of money in the bank, and she adds a little bit each week, right? Timothy goes to the same bank, he has some amount of money already in the bank, he adds the same amount of money each week, right? Their amounts may be different, but we could be looking for what? What are we looking for if it's a system of equations? We're looking for what they have in common. At what point they will be the same, right? So based on the situation that they give you, you got to determine what type of function am I talking about? What is the solution to this function? So now we're talking about these quadratic functions, right? What does a quadratic function look like in real world? Where it looks like something that doesn't have a constant rate of change, but it has an average rate of change. Why? Because the speed or the rate changes over time. So let's say, for example, we got somebody who throws a ball, right? What happened initially, the speed is fast, right? Because of the initial velocity. It goes up in the air, but what's happening as the ball goes up? Gravity is pulling on it, which is doing what to the speed of the ball? Slowing it down. Then it's going to reach a point where the pull is equal to the force, right? And so now that ball stops. I mean, it doesn't literally stop, but it's a point where it stops going up and it changes direction. And now instead of increasing, that ball starts to decrease in height, right? And that is going to give us what type of function? Quadratic, because it's creating a parabola. Are you all following me? Okay. Then we have a situation where you may have, let's say, for example, you got a scientist that's working inside of a lab, right? And they have this, whatever y'all call these cups, and then they put a cell in it, right? And what happens? They put one cell in it, then it becomes 2 cells. Then the next day it's 4 cells. Then the next day it's 8 cells. Then the next day it's 16 cells. What's happening to the number of cells? It's doubling. Is doubling the same as increasing by 2? Is it? Are the cells increasing by 2? What are they doing? They are multiplying by what? 2. They are doubling. They're not adding 2, which is linear each day. They are multiplying by 2, which then is what type of function? Exponential. So now I know I'm not dealing with linear. I'm not dealing with quadratic. I am dealing with a exponential function. Are you all following me? All right. Let's say, for example, you have somebody that's on, say, a racetrack, right? And their speed, they're increasing in speed. So let's say every minute their speed is increasing, let's say by 2 miles per hour, right? So it's going up by 2, another 2, another 2, another 2. And then they get some kind of signal in the car that says, hey, you got to stop this car. So then what do? Decrease by 2, decrease by 2, decrease by 2, decrease by 2. What type of function is this representing? Absolute value. Absolutely. Why? Because initially it was the same thing happening over and over as an increase, but then it reached some maximum point and started to do what? Decrease by the same rate. Are you with me? So now we have a line going up, but then we also have a line going down. So now we have 2 linear functions at the same time happening, right? So then what do we end up having? We have a V, an absolute value function. So why are we looking at all 4 of these? Because the goal is that you guys will be able to look at a real world situation and be able to tell, is this linear? Is this quadratic? Is this absolute value? Is this exponential? And then you can be able to find what's missing or what's unknown or solve the problem based on everything you've learned about all these functions. Are you all following? So our focus for today is quadratic. And we have been on quadratic functions all semester, right? All semester. And we have learned various ways to solve a quadratic function. But when they tell you to solve a quadratic function, what are they looking for? What are we looking for? The what? The x-intercepts. What's the other name they may say? Roots. They may say zeros. They may say, is it the starting point? Are our x-intercepts a starting point? What do we call a starting point? Y-intercept. Is a y-intercept the solution? No. It is a key feature. It is the point where our parabola crosses the y-axis, but is it a solution? No. When they say find me the solution to this quadratic function, they are specifically looking for the x-intercepts. So now what might they say to you around these quadratic functions? They may say, Tashandy threw a ball in the air. At what point this ball reached its highest height? What are they looking for? They're looking for the max. Give me another name. They're looking for the what? They're looking for the vertex. Are you all with me? Now, is that the solution? No. But is it the answer to the question? Yes. And I know how to find a vertex. Are you guys with me? What if they say to me, Tashandy throws the ball and the ball goes up and then it hits the ground at a certain point? How long does it take this ball to hit the ground? What are they looking for? They're looking for what? Are they looking for the y-axis? So you got a y-axis, you got an x-axis, right? The ball is here. What is on the y-axis?
The ball.
But when? At its starting point. Before she lets that ball go, that is the y-intercept, right? But then what happens to that ball? It goes up in the air, right? It reaches a maximum height, which is our vertex, and then the ball starts to fall and hit what? The x-axis. So for us, the x-axis is our ground. Are you all with me? And we can imagine a ball starting on the y-axis, and it's creating this upside down U. Are you all following me? Yes? So what do I have to be able to do, Miss Stampley? I have to be able to see or read a real world situation, picture it, and think about what are you asking me to find, and then think of what math that I know that I can use to solve that problem. You ask me for the maximum height of something, I'm going straight to a quadratic function. I'm looking for the vertex. Are you all with me? Even if you ask me what's the lowest point that a swing reaches, right? You got a swing, and a swing does like a pendulum, right? It goes from left to right. We put Gartega on a swing at the park, and we're pushing him. What happens? What am I looking for? Am I creating a parabola?
Yes.
I am, because I'm going to pull him back and start him off, right? And then I'm going to let him go, right? Here's my y-intercept. I let go to the chains. He goes down. He reaches a lowest point, and then he what? Goes back up. Does he ever touch the ground? No, because he's sitting on a seat. Are you all with me? So I may ask you, if we start here with Gartega, this is his equation. Can you tell me how close Gartega gets to the ground before he goes back up again? That is the minimum. Are you all with me? But you got to know that's not linear. That's not exponential. Gartega don't go up and keep going up, going up, going up, going up, and going up, right? Like he has to go up and come back down. Are you all following me? So you got to know in your mind, oh, this models a quadratic function, so I'm going to shift my mind to dealing with quadratics, right? So today we are going to work on quadratics, but specifically solving them by graphing, right? Because we got this list, and we talked about all the ways in which you can solve a quadratic function, right? We can use a table, right? We could use what? Graphing. We could use factoring, which we've already done, right? We also could do what? Quadratic formula, which we've already done, right? So we got these other methods, and a few of us, if you're in my study hall, we have also done completing the square, right? But what are we learning today is how to solve, how to find those x-intercepts from a graph. Are y'all following me? And it's going to involve us also using a table, but then I'm going to show you a quick trick that we know, okay? So it's going to take me a little bit, but I'm going to walk you through everything because I want to take my time and I need everybody fully focused. Are we all good? Yes. So on your desk, you have this paper. So let's walk through what we see. First of all, what form is this function in? It's in vertex form. And vertex form gives us the vertex. Give me another form that we have for a quadratic function. Standard. Let's talk about standard for a second. Standard form is y equals ax squared plus bx plus c. What does standard form give us? Just looking at it, what does standard form give us?
A and B.
So what does it tell me about? Yes, it gives me an A, it gives me a B, and it gives me a what? C. What does the A tell me? It tells me the concavity. How much this thing use up or down, right? If it's positive, how does this thing use? Up. And therefore I have a maximum or a minimum? Minimum. If the A is positive, it use up. So that means you have a minimum. You have a lowest point, right? What happened if the A is negative? It used down, which now means you have a maximum, okay? So you can tell whether or not you got a lowest point or a maximum point, a highest point, based on how the A looks, right? What the A is telling you. What does the C tell me? My y-intercept, which is what? What our starting point is, right? So the C in real world context tell me where we started, right? It is the point where our parabola crosses the y-axis. Is everybody following? Now the B tells me something too. What does the B tell me? It tells me that I have a shift. Now the B by itself doesn't tell me which way we shift, left or right, but it tells me there is a shift. A shift existed. Are you all following me? So when we look over here, it is that initial velocity. It's that extra push that came, right? So if there was no push, then I don't have a B. There was no shift. Are y'all following me? Remember how we talked about if you got an object and it just rolls off something? Yeah. You got a quadratic function because it got a highest point. It's going to turn down, right? But is there a shift? No, because it just rolled off. Are you all with me? But if I push it, what happens now? I give it this initial velocity. Now it has a shift. Are y'all following me? And it rolls down. If there is no shift, the highest point is the vertex. It's sitting on the y-axis. It sits on the y-axis. It just rolls down. Are y'all following me? But if there is a shift, what happens? It's going to go up a little higher, and then it's going to do what? Come down. Are y'all following? So if there is a B, that means there is a shift. If there is no B, and let me show you what I'm talking about. We said it's y equals ax squared plus bx plus c. If there's a B, there's a shift. That means the parabola, if this is the y-axis, the shift is either to the left or it's going to be to the what? Right. That means that parabola, the vertex either sits to the left or that vertex sits to the right. But it shifted somewhere. Are y'all following me? However, if it says y equals ax squared plus c, there's no shift. That means it is sitting exactly on the y-axis. It used up or it used down, but it's sitting right here on this line. Are y'all following me? Yes? What happens when there is no c and it's just ax squared? Is there a shift? No. Is there a starting point? Ooh. What is the starting point? If I don't see it, then what is it? Zero. It's zero. That means the starting point is zero. So where is zero? If this is the x-axis, right, and this is the y-axis, then where is this parabola sitting? Right here. Are y'all with me? It sits on the origin. It either use up from here or it use down. Are you with me? Is everybody following? Now that A, what does that A tell us? Yeah, it tells us if it use up or use down, but it also tells us what? What about the concavity? What does the word concavity mean? Bend. So that A also tells me if it's wide or if it's narrow. If it has a vertical stretch or if it's vertically compressed. Are y'all with me? Here's how we remember that. If that A is a fraction, figure that out. If that A is a fraction, it's compressed. Why? Because a fraction is real close to zero, isn't it? Yeah. Yes? When the line is like this, that means my a is 0. It's not a quadratic function. It is a linear function. Why? Because there is no a. If the a is 0, there is no bin. Are you all following? But if I got a number between 0 and 1, 1/2, 1/3, right? 1/5, 2/4, doesn't matter. If that a is a fraction, there is compression. Are you with me? Why? Because it's between 0 and 1. Now, what happens when it's bigger than 1? It starts to stretch, right? Now I have vertical stretch. So vertical stretch is it's narrow, or a is less than 1, and it is wide, which means compressed. Are y'all with me? I imagine if you got a rubber band, you cut it, you put your feet under it, and you pull it. What happens? The more you pull it, aren't you stretching it? Is it getting wide or narrow? Narrow. So if the thinner it is, the more narrow. It's vertically stretched. Are y'all with me? But if I let go, it becomes wide. Are y'all following? That is compressed. It's like when you take something and push it down, what are you doing? You're compressing it. You're making it wide. Are y'all with me? So do we understand the difference between stretch and compress? Yes? What about if my a is 1? Think.
It's quadratic because
It is quadratic. All of them are quadratic. Whether it's stretched or compressed, it's still going to be quadratic. But if my a is 1, is it going to be stretched or is it going to be compressed? It's going to be neither. Why? Because in order for it to be compressed, it has to be between 0 and 1. Can it be equal to 1? No, it has to be less than 1. And if it's stretched, then it's greater than 1. So if it's equal to 1, it's not stretched or compressed. Does that make sense? Is everybody following? Yes? All right. So let's get into solving this thing by graphing. But let's walk through a few things. How do we know that this is vertex form? What does vertex form give us? The vertex. And what letters do they use to represent the vertex in vertex form? H and K. Now the vertex is just a point, right? And we know that a point is a set of ordered pair, right? It's two coordinates, an x coordinate and a y coordinate. But here, they refer to that x and y, that point, as H and K. Why do they do that? They do that because they're letting us know this is not just any point. This is a special point. This is the vertex. So anytime somebody say H and K, you already know this is my vertex. It's either my highest point or it is my lowest point. Is everybody clear? Yes? So when we look at this, H and K are our vertex. And they tell us here. What do we see in front of the H? What does that mean if we see a negative sign?
take the opposite.
It means switch. Take that opposite sign. So whatever you see, you're going to take the opposite of that. Do we see that same minus in front of the K?
No.
So are we going to switch the K? No. So when we look at our form, at what we have here, what can you tell me is going to be our vertex? 5 and what? Negative 32. Our vertex is 5 comma negative 32. Does that make sense? Yes? Why are we saying 5 and not negative 5? Because you got to switch it. It says in the formula that your H of your vertex is the opposite of whatever you see here. Whatever we see here, you take the opposite of your H, and that is the X of your vertex. So when I look at this, I see a negative 5, and the opposite of negative 5 is positive 5. But we do not switch the K. Because does it tell us to take the opposite of K? No. So then I'm going to leave this K as it is. It's negative 32, so my Y of my vertex is negative 32. Does that make sense? Yeah. Does everybody understand that? Yeah. Yes. What else does vertex form give us? Not just our vertex, it gives us our... What else? It does. What else does it give us? Do you see a starting point here? What would be the starting point? What gives us our starting point? It does. It does. But what gives us our starting point? Which form gives us our starting point? Standard, right? Vertex form gives us our vertex, but it also gives us our A. Doesn't every form give us our concavity? Every form. Standard form, A's out front. Vertex form, A's out front. And then we have our factored form. The A is also where? Out front. So all three of them gives us our concavity. Are y'all with me? So what else do I know about this? I know that my concavity, my A is what? 2. So am I going to be vertically stretched, or is this vertically compressed? Vertically stretched. Does that make sense? Yes? All right. Now, I want us to look at a little bit. I want us to look at this. So, they've given us a few hints here. Y-intercept. If I want a y-intercept, I got to plug in a 0 for the. If I want to find a y-intercept, I must plug in a 0 for the x. Y'all, this is not rocket science. If you're trying to find the y-intercept, you're trying to find where it sits on the y-axis. That means the x is going to be 0. What if you're trying to find the x-intercepts? What do you have to plug in for the y? 0. That's just how we rock, right? If I'm looking for the x-intercept, you plug in 0 for the y. If I'm looking for the y-intercept, you plug in a 0 for the x. So we want to hold on to that. What else do we want to know? Okay, we get an axis of symmetry. What is an axis of symmetry?
The x coordinate of the vertex.
It is the x of the vertex, but it is also the line that reflects our parabola, right? Where is the axis of symmetry in relation to the parabola?
In the middle?
In the middle. It goes through the what?
The vertex.
It goes through the vertex. Are y'all with me? So I got a parabola. I got this line that goes smack dead through the middle. What does that line do to my parabola? It splits it in half, creating 2 reflections of one another. Are y'all with me? So if I got a point that's 3 units to the left here, then I'm going to also have a point that's 3 units to the right here. These points are going to reflect each other, and that's going to be important later when we're trying to build our parabola. Are y'all following? Yes? All right, so we got an axis of symmetry, which is the x-coordinate. So let's look at that for a second. We know our vertex is 5, -32. Can you tell me what then the equation of your axis of symmetry is going to be? If the axis of symmetry, and I heard Aiden say it, is the coordinate, the x-coordinate of the vertex, what is the x-coordinate of the vertex? Think about what I'm asking. What is the x-coordinate of our vertex? What is our vertex right now? What is the x-coordinate of that vertex? Is it -5? What is our vertex? 5, -32. What is the x-coordinate? It's 5. So guess what the axis of symmetry equation going to be? It's going to be x equals 5. This is the equation for your line that goes through your vertex. Now make that make sense. Why is it that the equation is x equal and there is no y anywhere to be seen in that equation? Why is there no y involved? Think about the line that's going to go through the vertex. What does that line look like? Does it touch the y-axis?
No,
It's never going to touch the y-axis. What kind of line is it? Describe it. It is. All these lines are straight except for the parabola. What type of line is it? It has a name. How does it run?
Up and down.
It runs up and down. What's the name for up and down?
Horizontal.
Is it horizontal?
The vertical.
Is this horizontal? Is this horizontal? Is this vertical? This is what?
Vertical.
This is vertical? Oh, this is bad.
Vertical is going up and down.
Vertical is going up and down. Horizontal is going left to right. So what is this? Horizontal. What is this? Vertical. I don't need to pull up verticals on the Google, do I?
No.
Do we need to ask chat? Okay, so what is vertical? Think about, in my house, we have a sliding door, right? And what hangs over that sliding door are blinds, right? Those blinds, I can twist the little thing and they open. and then I could take the cord and push them and they go back, right? Those blinds that hang like that up and down are called verticals. They're called vertical blinds. Why are they called verticals? Because they hang up and down. When you think about the sun, me and my husband and my son likes to go to the beach sometimes early in the morning to see the sunrise, right? If you go to the beach to see the sunrise, you're going to see a horizon. What is that? That's when you look out and you see where the ocean ends. It looks like it's ending. But why is it not ending? Because the earth is curving, right? But it looks like it's ending, right? But it looks like a straight line out there. Are you all with me? And then when the sun comes up, before you even see the sun, you see the orange rays, right? So as it lifts, you see this orange that goes all the way across, straight across. What do we call that? We call that a horizon. But why is it called a horizon? Because the light is horizontal. Are y'all following me? Are y'all following me? These names come from somewhere. We ain't just pick names to call stuff. There's a definition, right? So when something is straight up and down, like the blinds in my house, this is called verticals. And when we see something going left or right, like the sun rising over the ocean, it is horizon or horizontal. Are y'all all following? Yes? Glad I can help y'all with that small vocabulary lesson. All right, so there's something else that we can see from vertex form. We haven't really talked about it, but we can see it. We already said that we can see the vertex, obviously, right? Which is our x and y of our highest or lowest point, max or min. But then we can also see, because we can see the vertex, we can see the shift. Or as you referred to earlier, the translation. What does a translation mean? Do y'all remember when y'all was in geometry and they had reflections? When y'all did geometry in 8th grade or 7th grade, you did reflections and you did translations, means something slides. And then you did reflection as the flip, translation as the slide. And then you got rotations, which is the turns, right? So we did all that stuff. You'll do it again next year. So if you missed it, it's okay. You'll get it. You'll catch it. But translation is trans and SL, slation, translation. And we always used to teach that SL reminds you that it's a slide. That means things move. It didn't flip. It didn't turn. It just slides. Well, that's what happens with our parabolas. Because all parabolas originally start on the origin. Are y'all with me? And the origin is right in the center. And then what happens? It slides. Where does it slide? It slides according to the vertex. Wherever the vertex is, that's where it slid. Think about it. The vertex starts on the origin. What is our vertex? 5, negative 32. What does that tell me? That tell me it moved left or right?
Left.
Which one?
Right.
5, negative 32. Where am I going?
Left. Right.
So, first coordinate is a 5. That's the x. Where's 5 in relation to 0?
Right.
To the right. So where do you go if you're going to 5 on the x? To the right. If I was doing a negative, I would go to the left. Come on, stay with me. Translation, we sliding. Where's 532? I start on the origin and I go to the right. How many? 5. Uh-oh, here go the big question. Now where do I go? Down. Down how many? 32. All right, here's an even bigger question. So where am I?
Quadrant 4.
Quadrant 4. Excellent. Ready. Absolutely. Think about it. Great job, Aiden. Watch this. This is the coordinate plane, right? Miss Stephanie, why you put that C in the middle? Because that's how it rotates. That's how we label it. So this is the y-axis. This is the x-axis, correct? So this is quadrant 1. Ethan, stay with me. Talk to me. You'll stay here with me. This is quadrant what? 2. This is quadrant 3. And this is quadrant 4. We use Roman numerals to name them, right? So it's 1, 2, 3, 4. So if I am starting here, and I'm telling you all parabolas start here. Y'all with me? Y-intercept is 0. Shift, your B is 0. You ain't going nowhere, right? That's where they all start. Then what happens? With ours, we had a vertex of 5, negative 32. So where do we go to get to 5? To the right 5. And then we did what? Down 32. So where's our vertex now sitting? It's sitting in the 4th quadrant. Are you all with me? Do you follow? So now here's another question. If your parabola is sitting in the 4th quadrant, does your parabola U up or down? Does this one U up or down? Does it U up or down? I ain't talking about down, 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 down. Wrong. What was our A? What is our A? Is that positive or negative? So then which way does this thing U? So why y'all all yelling down? What is happening? Think for yourself. So I'm asking you about our parabola. It has a vertex of 5, negative 32. To the right 5, down 32. And it's going to U up. So if that's the case, don't yell it out. Just think. We have a vertex of 5, negative 32. And our parabola U's up. How many solutions are we going to have to this function if a solution is the x-intercepts? Think. How many solutions am I going to have if raise your hand when you get the answer, if this vertex sits in the 4th quadrant and it U's up? How many solutions? 2. Is that correct? Yes. Why? Because this thing gonna do something like this, isn't it?
Yes.
And so now you're gonna hit the x-axis 2 times. Do we see that? Yes? Now, what if I told you that you have a vertex of 5, negative 32, and you have no solutions? Your vertex is the same, 5, negative 32. But I'm telling you there were no solutions. What does that mean? That means it didn't touch the x-axis, which means what? Which means what? There's no solution, but that means what about my equation? What in my equation would have to change? Because with my current equation, you got 2 solutions. But I'm telling you there are no solutions. But you got the same vertex. So what does that mean? What had to be different? Your A had to be what? If your A is 0, we don't even got a quadratic function. We got a linear function. Your A would have to have been what? Negative. Because watch this. If you got the same vertex, the only way you don't touch this is if you're doing what? You got to be U'ing down. So now, if your vertex is below the x-axis and you're U'ing down, you're not going to have no solutions because it's not going to touch the x-axis. Are y'all following? Are you following me? I'm trying to get you to understand how all this stuff come together and makes sense. Are you all following? So how do I get no solution? Here's one way. What's another way to get no solution? What if my vertex is above the x-axis? Then it would have to do what? U up. If my vertex is above the x-axis, right? If it's above, the only way I have no solution is if this thing does what? U up. Now I'm not going to touch the x-axis at all because remember, what is the solution to a quadratic function? It is the x-intercepts. That means you got to touch the x-axis. So if I'm telling you there's no solution, that means you don't touch the x-axis. How is it that this does not touch the x-axis? Get off your hand. How is it that this don't touch the x-axis? That means it has to do what? U up, and the vertex got to be above. But if the vertex is above and I say there's 2 solutions, then that means that this thing U'd down. Are you following? Yes? I'm just trying to intertwine everything, get you to see the whole point. Are you all following? Raise your hand if you understand what I'm talking about. Okay, of course everybody gonna say they understand. Do you understand? Is your hand up? What? What's happening? Okay. All right, so are we good with this first, second, third, fourth quadrant? Yes? Do we understand all that? Yes? All right, now let's get into our problem. All right? So I'm going to take all this off of mine. You can leave it on yours if you wrote it down. So now let's keep going. So what does this vertex form give me? 1, vertex form gives me my vertex, the x and y of my vertex. Very obvious. What else does vertex form give me? It gives me my A, which is my concavity, right? Do I U up? Positive A. U down? Negative A. How wide? Right? Less than 1. How narrow? Greater than 1. Right? So we got that part. Now, I just told you there's something else that it gives us. What else does it give us? It gives me my translation. It tells me where I moved from the origin. Are y'all with me? And what do I have to do to find that out? All I got to do is look at my vertex, right? My vertex is 532. So where did this thing move?
Right.
Oh, we all got it right this time. Where did it move?
Right.
To the right, how much?
5.
And then what? Down 32. And ended up where? In the fourth quadrant. Are y'all following? Everybody clear on that? Yes? All right. So now let's move into solving this thing. You got to keep in the forefront of your mind the goal. You got to. What is the goal of solving this quadratic function? To find the x-intercepts. We are looking for the solutions. Are y'all following me? Yes? All right. What if somebody asks you, what is the maximum height of this ball? Are you looking for the solution? No, you're looking for the what? Vertex. So that's going to be the answer to the question is the vertex, but that is not the solution. The solution is the x-intercepts. Are y'all following me? What else might they call them? Zeros, roots, solutions, right? X-intercepts. All right, let's go. So, without doing any work, what key feature can I give you right now? Vertex, duh, right? What is that going to be? 5 and negative 32. As soon as I have the vertex, I also have something. What is that something?
Axis of symmetry.
I got my axis of symmetry. Watch this. What is the axis of symmetry? X equals H.
What?
Think. X equals H.
Because H is the
H is the X of the vertex. Isn't this HK?
Yes.
Yes? What is the H?
5.
So then X equals what? 5. Oh.
Same thing.
Duh. Same thing. Same thing. Matter of fact, look above Timothy's head, right by the red firelight. What does it say? Axis of symmetry what? X equals what? H. Same thing. Does that make sense though?
Yes.
I don't want you to just write what I'm writing. I want to make sure it makes sense to you. Does it make sense? Yes. All right. So what can we get from vertex form? Immediately the what? Vertex. And then we also can get what? The axis of symmetry. Let's add something else in here that we don't have here yet. Let's put down the translation. SL being the key letters. Slation, how it moves, how it slides, right? How does this thing slide from the vertex? It goes what?
To the right.
To the right what? 5. And then it goes what?
Down.
Left. It goes back left.
Down.
Right 5. And then what?
Down.
It goes down 32. That is my translation. That is my move. That's what happened to my parabola. How do I know that? Because my vertex starts always at the origin. And once we see it, right, it's telling us where it moved to. Are y'all following me? Yes? Does my parabola you up or you down?
Up. Down.
You.
Up.
Why are we guessing? How do we know if it's Ewing up or Ewing down? Your A, if your A is what?
Positive.
Positive, then it does what?
Up.
You up. If your A is negative, it does what?
Down.
You down. So our A is what? So then it use.
Up.
Come on now. Don't be trying to beat nobody to the answer. Just think. If our A is positive, this thing use up. Question, is it wide or narrow? See, trying to beat somebody to the answer instead of just thinking first. Is it wide or narrow? Is it compressed or stretched? Stretched. How do we know it's stretched?
Greater than 1.
What is greater than 1?
Your A.
Your A. So it's stretched, right? All right. We just wrote all this down, y'all, like 2 minutes ago. It's right here. Stretched. Come on now. All right, let's go. So what's next? Let's graph this thing. Right? So let's go here. If you're telling me to graph by vertex form, then I'm going to just go ahead and graph my vertex. Y'all with me? Stay with me. This is my favorite form to graph from, and I'm going to show you why in a little bit, but I'm trying to get this thing to be a little thinner. All right, so 532. What do we do?
Right 5.
Right 5.
Down 32.
Down 32. Now, is 32 clearly laid out for us?
No.
No, so that already tells you that when you're graphing, that it may not be exact, right? It may be an approximation. So should you lean heavily on the graph? Not if you got another option, right? But you can do it to give yourself an idea or to be able to answer other questions, okay? So I'm going to go over to 5, and I'm going to go down to 32. I'm just going to make me some little marks here. 31, negative 32, 33, 34. And I'm just put a little dot here on this 32. So I'm at 5, and I'm going to write it. 5, negative 32. Grab your calculators. We're going to do some work. All right, so, Miss Stampley, I need more points than that. Okay, so let's get some more points. Why? Because I am using the graph that I draw, right? I am using the graph to help me find my solutions, which means I need points that are going to lead me to this x-axis, right? So I need me a few points because I'm way down here at negative 32. The x-axis is way up here. So let's see what we're going to do to get these other points. So let's go off to the side and let's make ourselves a quick little t-chart. And this is the one thing that we learned with linear, absolute value. It doesn't matter what. We always can make us a t-chart, plug in an x, and get a y. And that'll give us points, right? So I'm looking at this, right? And I'm looking at my point here. I already know this thing is going to U up, right? Because our A is positive. So what I want is I want some points around this point. Are y'all with me? Y'all understand that?
Yeah.
I don't want to pick a point right down here like 13, because I don't know if my parabola is going to go that wide on this graph, on this coordinate plane. I don't want to pick a point all the way over here, negative 3. I want to pick a point that's somewhere around my vertex so I can see how this thing starts to curve. Are y'all with me? So give me a x. 5. Give me, well, not 5. Why I don't want 5? Because we already got 5, right? So,
4.
8.
okay, I hear 4 and I hear 8. Let's go with that. Let's do 4 and 8. Miss Stapley, what am I going to do with them? Y'all know. What am I going to do with these two x's? I'm plug them in. So grab your calculators. We're going to plug them in to our original function, which is right here, right? So we're going to have y equals 2 times 4 minus 5 squared. Don't forget that squared. Minus 32. Y'all with me? And then we're going to have y equals 2 times, what else we had? 8 minus 5 squared minus 32. Now, what am I doing? I'm plugging in an x so that I can get a y, so that I can have an x and y that I can plot. Are y'all with me? Why do I want to plot points? Because I want to make the parabola so I can see how it bends and where it ends up on that x-axis. Are y'all following?
Yeah.
Do we understand why we're making points? Do we understand why we're plugging in the x? Yes, because it says y equals. So if you do the math, it's going to give you the output when you put in 4. Y equals. If you do the math, it's going to give you the output of y when you put in an 8. Does that make sense? So what is this one going to give me? It's going to give me 4 something as one order pair. What is this one going to give me? It's going to give me 8 something. Whatever I get from this is going to give me that other order pair. Are y'all following? Now, is that going to be enough? I don't know. But let's plot and see. Okay? So, if we start with these 2 points, grab your calculator. And let's put in our calculator. I don't want any of these. I want this. All right, so what are we putting in our calculator? This is PEMDAS we got to follow, right? Yes, so according to PEMDAS, what do you always do first?
Parentheses.
You got to get rid of them parentheses. You got to simplify those parentheses first. After parentheses get simplified, then we're going to do what? Exponents. After we do exponents, we're going to do multiplication and division if we got that. And then we're going to do addition and subtraction. Y'all know we following PEMDAS, right? Yes. All right, so you're welcome, baby. So let's go. First thing I'm going to put in my calculator because I'm dealing with this first. I got to simplify that first. Order of operations are very important, and you got to press equal. Otherwise, it's going to do things out of order for you, okay? So, what am I starting with? 4 minus 5. I heard somebody say 2 times. Do we do multiplication before we do parentheses? No. So, we got 4 minus 5 equals. What do I get? -1. Now, what do I do? This is -1. Now I got square, multiplication, and subtraction. Which one am I going to do first? Exponents, multiplication, or subtraction? Exponents. So how do you square that? Right here. X squared. What do we get? 1. -1 times -1 is +1. Then what am I going to do next? Times 2. Times 2 equals 2. And then I'm going to do what? -32 equals. What do I get? -30. So 1 point on this parabola is 4 -30. Do everybody see what I'm doing?
Yes.
I am actually using a table to help me graph. Does that make sense? Yes? All right. So over here on my T-chart, it's going to be 4 -30. Everybody following? Yes? All right. Now let's go back and do our second one. Clear it out. Tell me what to put in.
8 minus 5.
Bless you. 8 minus 5. I put 2. 5 equals. Yes, we get 3. Then what?
Squared.
Square it. Then what?
Times 2.
Times 2 equals. And then what?
32.
-32 equals. And what do we get?
14.
-14. So our second point over here is -14. Now, we may need more points than this, but let's plot what we got so far. Y'all with me? All right, so if we started at 5 -32, what are we going to plot next?
4, 30.
4 -30. So I'm here. What do I go from 0?
Right 4.
Right 4.
Down 30.
Down 30. That's going to be right here. Nice clean point. Everybody see that?
Yes.
And I'm going to put here 4 -30 just so I can see that. Any questions? You struggling, baby. You about to mess it up for everybody. You know. Wake up. What's my next point? 8 -14. Where do I go?
Right 8.
Right 8.
Down 14.
Down 14. Where this is -15. So I'm going to be a little bit above that. I'm going to put a little point here. That's going to be 8 -14. And label your point so you can just see where you at. Now I'm looking at this and it's looking a little crazy. Because I can see where it may be trying to be a parabola, but I can't really do nothing with that. I need more points. Y'all agree?
Yeah.
There's something that can help us at this point. What can help us?
When you put down the vertex in the middle, you can just like go to the other side of it.
Absolutely. Clap it out for him. That was great. Right? He's saying, hey, draw your little axis of symmetry down the middle. And then guess what? What does the axis of symmetry do? It lets you reflect things, right? So if you got a point on the left, you can put a point in that same spot on the right. So let's do that. Let's create our axis of symmetry. I'm going to put a line right down the middle through this 5 because our equation was x equals 5, right? Everybody see that? Yes? Now, what do I notice? I got 1 point to the left of my axis of symmetry. So what can I do over here? Put it on the right. This is 4, negative 30. It's 1 to the left. So I'm going to put 1 at 6, negative 30. That's 1 to the right. Does that make sense? Class?
Yes.
Yes. Do you see what I just did?
Yes.
1 unit apart. Now, let's do the same thing with this other point. This is sitting on negative 14, but it's 1, 2, 3 to the right. So on negative 14, I'm going to put a point 1, 2, 3 to the left. Does everybody see that? Now I'm going to ask you, do you have enough points now to make a parabola?
Yes.
Yes. But here's my issue. I'm still freehanding it. Y'all see that?
Yeah.
So my goal is to solve it, which means to find the solution. Now, if they just would have told me sketch a graph of this quadratic function, I'm sketching this thing and be done, right? Because that means they expect for it to be off a little bit, right? Like they ain't looking for precision. But if they ask me for the x-intercepts, they're looking for precision. So I need to put more points, because remember, the more points, the more accurate this thing is going to be. So let's see where we can find some more points. So I want to take this opportunity to show you something a little bit different. Obviously, what can I do? I can put more numbers in my x, plug them in, give me some more y's, right? That's obvious. We can do that. But I want to introduce you to something a little bit different. It's called the 1-3-5 ratio. What did I just say? 1-3-5 ratio. So parabolas are perfect. They have a perfect bend. And it doesn't matter what parabola you do. It's always going to have a perfect bend. Well, where does that perfect concavity comes from? It comes from the 1-3-5 ratio, right? So what happens? You know how we have a table? We did these last week, right? Well, we got a table and we're trying to figure out if it's linear, quadratic, exponential, right? What's true about the x's? They are always how many spaces apart? 1, right? They're always in order by 1, right? So x's affect horizontal movement, correct? Y's affect vertical movement, right? So if my x's are always 1 unit apart, when we get ready to graph these points with this 1-3-5 ratio, we always go to the right or the left 1, because the x's are always just 1 space apart. So I will always go right 1 and then up something, right 1 and then up something else, right 1 and then up something else. Are y'all with me? So the idea here is to remember that you always go to the right or left 1 up something, left 1 up something, left 1 up something, but you always go left or right 1. Is everybody good with that? The other part of that is the 1-3-5. So watch what I show you. I'm going to go over here to the side, and I'm going to put, I want to find me some space. I'm going to put 1A, 3A, 5A. Do what I'm doing. I didn't just put 1-3-5. I put 1A, 3A, 5A. Are y'all with me? What do you notice about these 3 numbers? They're odd, right? 1, 3, 5. What will be next? What will be next? 7A. Then what? 9A. And then what? 11A. It just keeps going, right? This is, you can always, always, always use this shortcut instead of making a table. Are y'all following? All right. What is my A? 2. If that would have been a negative 2, then all the other numbers would have been negative also. Not the 1-3-5, but the results, right? So let's see. What's 1 times 2? 2. What's 3A or 3 times 2? 6. What's 5A or 5 times 2? 10. Just to keep going. What if I had 7A? What would it be? 14. Now, why I'm doing this? Because this is giving you a shortcut or a cheat code to getting more points without having to use a table. Right? Why? Because every quadratic function, every parabola has that 1-3-5 ratio in its bend. So watch what happens. I'm going to go right 1 and then up what? 2. Then I'm going to go right 1 and up what? 6. I'm going to go right 1, then up what? 10. I'm going to go right 1 and then up what? 14. And every time I go up, I'm going to put a point when I finish. Y'all with me? And it's going to create my bend. And then once I can do one side, guess what I got to do to get the other side? I just reflect them over my axis of symmetry. Are you with me? So let me model for you how we do that. Now, don't go right one and up 1 and right one and up 3 and right one and up 5 unless these are all 1s, right? If your A is 1, then it's going to be 1 times 1 is 1. 3 times 1 is 3. 5 times 1 is, right? But this is just to get you what you need to do as far as your rise, okay? So now let's go here. We started the vertex. I'm going to do it in a different color because I want you to see the difference, okay? So we always start our vertex, right? Calculators on your desk. I need it nice and clean. So clear it out. What am I always going to do? Go right 1. And then once I go right 1, I'm going to go up what? 2. So right 1, where are we right now? We're at negative 32. Clear your calculators out. Put in your calculator, negative 32. And don't erase till I tell you. Put negative 32 in your calculator. Once you put that in your calculator, how much are we going up? 2. So put plus 2 equals. What do we get? So that means I'm going to go right 1 and I'm going to go up to negative 30. Didn't I hit that point that was already there? Yes. All right. So we've done this one. Now what's our next one? What are we going to do next? What's our next move? Right 1 always. And then what? Up 6. Okay. In your calculators. What number is in your calculator right now? Negative 32. So we're going to go right 1, but then we say we have to go up 6. So in your calculators, put plus 6. What we get? Negative 24. So I'm going to go right 1, and then I'm going to go up to negative what? 24. Do everybody see that? You see me creating more points? Yes? All right. And what's this ordered pair? This is going to be 6, negative 24. Everybody agree? Am I wrong?
No.
Negative 32. Did we go up 6? Yes? Up 6 takes us to negative 24. Everybody agree? Y'all sure? No. Shouldn't that be 26?
Yes. That's what A gave me.
It's negative 32 plus 6.
Negative 32 plus 6 is
No,
it's
negative 26. What were y'all on last time?
Negative 30.
Oh, I'm sorry. That's correct. Y'all are right. I didn't put my point. Okay, so let's go back. I'm sorry. So what is this point right here? I didn't put that. This point is 6, negative 30. Correct?
Yeah.
Okay, so you got negative 30 in your calculator, right? Okay, now I'm going to do what? Go right 1 and go up 6. Where does that put me? Negative 24. So then this ordered pair is going to be what? 7, negative 24. Correct. Sorry about that. I missed the point. Are y'all following? Everybody on the same page now? Yes? What's sitting in your calculator right now? Negative 24. All right. Now, we get to do it again. So what are we going to do this time? We're at negative 24. We did our 6. What are we going to do this time?
Right.
Go up, go right 1, and then up
10.
10. So in your calculators, you're at negative 24. You're going to put plus 10.
Negative 14.
Negative 14. So then I'm going to go right 1 up to negative 14, and that's my next point. Y'all see it? Do you see how I'm still hitting those same points that you would have got from the table? Yes? All right. Now, after that, what do? I still haven't hit this thing yet. I could reflect them. But remember, my whole point is to find my x-intercepts. And I ain't there yet. So what do we do now? Because we're here. We did 10. Our next number is what? 14. So now I'm going to go right 1. And then you're going to put plus 14 in your calculator. What do you get? 0. So next I'm right 1. And I should hit right here. Now what is this?
Your solution.
That is one of my solutions. Are y'all following me? So what is this ordered pair? 9, 0. Is everybody following? Yes. Now, I could just do what? I can reflect. So, Notice this. This is 1 unit to the right, correct? We got 1 unit to the what? Left. Here, it's 2 units to the right of my axis of symmetry. So then I got to do 2 units to the left of my axis of symmetry. Now remember, if this says negative 24, you got to stay on that line, and you got to put it right in that same spot, but 2 units to the left. Does that make sense? Yes? Now we're here. This is 1, 2, 3 units to the right. This is 1, 2, 3 units to the left. We got that one. And then our last one is 1, 2, 3, 4 units to the right. So then 1, 2, 3, 4 units to the left. Now, do I have my full parabola? Yes. And do I have my solutions? Yes. But guess what? I don't got my y-intercept, because it stopped right before the y-axis. So I want to go again. Let me do it one more time. Right? So I'm here. We did the 7a. I got 1, 3, 5, 7. What's next? 9a. And so 9 times 2 is going to give us what? 18. So now this time I want to go up 18. So I'm already at 0. So I go right 1 and then what? Up 18. And here's my other point. Does everybody see that? And this is going to be 10, 18. Everybody see it? And how far is this from my axis of symmetry? 1, 2, 3, 4, 5. So if I want to see over here, I just go 1, 2, 3, 4, 5. And look, where am I hitting my y-axis? What number is that? 18. It's 18 high over here, right? So it's still going to be 18 high over here. Are y'all following? So then this ordered pair is what? Give me this ordered pair. 0, 18. Absolutely. Is everybody clear? Yes. Just for the fun of it, let's keep going. What's going to be next? I got 1, 3, 5, 7, 9, 11, 8. What's 11 times 2? 22. So in your calculators, you're at 18. You're going to put 18 plus 22. What do you get? 40. So guess what? I'm going to go right 1, and then I'm going to go up to 40. I'm maxed out now. That's 1, 2, 3, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. My parabola's done, y'all. Does everybody see that? Yes? Any questions about that? Does that make sense? So do you have options when plotting these points? Yes, you can either do it using a table, or you can do the 1, 3, 5 ratio. Are y'all following? Yes? All right, so let's fill out the rest of this. We got a few minutes. I want to tighten this up. So now, do we know our y-intercept? What's our y-intercept? What's our y-intercept? Where did our parabola cross the y-axis? At 18. Give it to me as an ordered pair. 10, 18. 10, 8. No, and you repeated it. 10, 18 is our y-intercept. 0, 18. 0, 18. But let's say you didn't fill out a graph to figure that out, right? How do you find an x-intercept? You plug in 0 for the y. How do you find a y-intercept? You plug in 0 for the x. So if I want the y-intercept, couldn't I just plug in 0 for the x? Couldn't I? That's a question. If I want the y-intercept, couldn't I just plug in a 0 for the x? So then let's do that. Let's say I don't have time to do this graph instantly and figure out what this thing is. I want to stop right here. I don't even see the y-intercept. No problem. Let's just do it algebraically instead of graphically. Work what I'm doing. Do what I'm doing. Y equals 2 times x minus 5 squared minus 32. What am I doing? I am finding the y-intercept. How do I find the y-intercept? I plug in a 0 for the x. Get your hand off your head. I'm tired of telling you. So now I got y equals 2 times 0 minus 5. Why I put a 0 in there? Because I'm trying to find the y-intercept, right? To find the y-intercept, you substitute a 0 for the x, right? Squared, don't forget that part, minus 32. Y'all with me? This part shouldn't even be hard. It's just simplifying, right? Y equals 2 times. If I got 0 minus 5, it's like the 0 not even there. So it's just minus 5, right? Squared minus 32. Y equals. Now, in your calculators, grab them real quick. Let's do this math. What am I putting in my calculator first? Order of operations. What do you put in first? Okay, you can do that. 0 minus 5, which is still just going to give you what? Negative 5, which is what I got. Then do what? Square. Hit that square button. Then what?
Times 2.
Do we do minus or multiplication first? Which one? Times multiplication. Times 2 equals. Then what? Minus 32. And what do we get? 18. So y equals 18. When x is 0, y is 18. That is my y-intercept. So what if I don't graph it? Do I have another way to find it?
Yes.
Absolutely. Is everybody clear? Yes? All right, our last and final thing that we need to look at is how do I get these solutions without graphing? We know what they are because we just solved for them using a graph, right? What are our solutions? X equals 1 and what? 9. Aren't those our solutions?
Yes.
Yes? But let's find them a different way. What methods have you already learned for solving a quadratic function? Factoring, quadratic formula, right? We just learned graphing, but we want to confirm that our answer is correct, right? Because you know graphs ain't always 100%, right? So which method do we want to use? Factoring. Let's use factoring, right? So if we use factoring, think about it. What do you need for factoring? What's the first thing you do? You find your A, B, and your what? C. And can you pull A, B, and C from Vertex form? No. What form do you pull your A, B, and C from? Standard. So guess what I need to do? I need to change this thing, convert it over to what? Standard form. So let's do that. Let's change this to standard form. We don't got much time, so let's hurry up. Y'all ready? All right, move pretty quick because I'm expecting y'all to know what to do. We ready? All right, let's go. So what do I have? I have y equals 2 times x minus 5 squared minus 32. Everybody agree?
Yes.
Yes. Now, from here, where do I go? Well, all you have to do to get it in standard form is simplify it. That's it. What does simplify means? No parentheses, no like terms. But I got parentheses, so I got to get rid of them. What does this mean when it say x minus 5 squared? X minus 5 squared. What does it mean when you say 5 squared? What does that mean? Multiplying it by itself, right? So it's saying this parenthesis, not the 2, not a negative 32, this parenthesis is squared. So doesn't that mean multiply it by itself? Mm-hmm. So then watch what I do. I'm going to put y equals, do what I do, 2 times x minus 5 times x minus 5 minus 32. Look at that for a second. Tell me if that makes sense.
Yes.
What is in the first line that is not in the second line? That's squared. Why is the squared no longer there? Because I actually wrote it out. Are you with me? Yes? This is exponent form. This is expanded form. Same thing though. Are y'all with me? Now what's next? According to PEMDAS, you got to get rid of these parentheses, right? So how am I going to get rid of them? I'm going to multiply. I'm going to use distributive, right? So I got y equals 2, because that 2 is out front, ain't got nothing to do with that. I am going to distribute. X times x is
X squared.
x squared. I'm putting all that in parentheses. X times negative 5 is negative 5x. Negative 5 times x is negative 5x. And negative 5 times negative 5 is positive 25. All that's in parentheses. And then I'm going to put minus 32. Why is that 32 not inside parentheses? Did we distribute to that? No. So that's outside, right? So now I'm here. Do I have any like terms that I can combine? What? Negative 5 and negative 5x. So I'm going to combine these two. Y equals 2 times x squared minus 10x plus 25 minus 32. Any questions from that line to the other one? Does this make sense? Yes? All right. Now, can I combine anything that's inside this parenthesis? Can I put these together? No, not like terms. In order to put them together, there needs to be same variable with the same exponent, and they're not. So I can't do nothing else with that, but I still got to get rid of this parenthesis. So what am I going to do next? I'm going to times it by 2. I am going to distribute that 2. Here, here, and here. Do I distribute this 2 to this negative 32? No, because that's outside. So what do I get now? Y equals 2x squared. 2 times negative 10x is negative 20x. And then 2 times 25 is positive 50. And then I just bring down minus 32. We good? Yes? Now, anything I can combine here? I'm always looking to see if I can simplify anything. 50 minus 32, what is that going to give me? 18. So now I got y equals 2x squared minus 20x plus 18. Now, does this make sense to me?
Yes.
Because then we say that our y-intercept was 18? Yes. And that's what I just got from the standard form, so I know I'm right. Are y'all with me? But I'm not done. Why am I not done? Because we are doing this so that we can solve it by factoring. Are y'all with me? And I haven't solved it by factoring. Why did I do this? I did this so that I can identify my A, B, and C so I can factor. Are y'all with me? So quickly, A equals 2. Matter of fact, even before I do that, question. Is there something I can pull out of all 3 of these and make this simpler? A 2. So let's do that. Y equals 2 times. If I got 2x squared minus 20x plus 18, and I divide all 3 of these by a 2, what's going to happen to these 2? Cancel out and leave me what? X squared. What's going to happen to these 2? They become what? Negative 10x. Y'all see that? What happens to these 2? 18 divided by 2 is going to be what? A 9. And then I'm here. Are y'all following? Now my A is 1, my B is negative 10, and my C is 9. The A is 2, but we're just factoring this part because we already pulled the 2 out. Okay? So now I got A times C equals 9, and my D and E, what am I looking for? 2 numbers that multiply to give me 9, but add to give me 10. What 2 numbers? You only got 3, 3, and 1 and 9. 1 and 9. So this is a 1, and this is a what? 9. But now watch this. I got a negative involved. So either one of these or both of these got to be a negative. Right? Because you got a positive 9 when you're multiplying. What's the only way to get a positive 9 when you're multiplying 2 numbers? They both negative or they both what? Positive. So what do these have to be? Both negative, because if they're both positive, then how do we get a negative 10 when we add them? Right? So they both need to be what? Negative. Now I got my numbers. Are we ready? You going to put them in a Punnett square? Watch this. When A is 1, you ain't got to put them in a Punnett square. That's another quick trick. When A is 1, you don't have to put them in a Punnett square. Watch this. Y equals 2 times. Do what I'm doing. Because my A is 1 and I factored out my greatest common factor, I don't have to put them in a Punnett square. Whatever this is going to go right in here. Watch this. First one going to be x minus 1. And x minus 9. This is factored form and it has been factored completely. Now I got to do is pull the opposite. What are my solutions? X equals 1 and x equals positive 9. And isn't that what we got in our graph? And we're done. Is everybody good? Yes? So when A is 1, do I have to do the Punnett square? Whatever I find here, that's what I plug in and I set them equal to 0 and solve. Everybody good?
Yes.
All right, can you